Okay, we're going to use both a calculator and non-calculator methods for solving, or a calculator method for solving estimates for these. An estimate is a rough answer. We're going to use a mathematical method which allows us to say it is definitely between two numbers is the solution for these equations. Normally for these equations you get told there is an answer between, and in this case I'm going to tell you there is at least one answer between 3 and 4. There may also be other answers elsewhere. I know, because of the nature of this equation, that there should be at least one and maybe 3 answers to this. So the technique is quite important. It's not solving an equation though. These are estimates of solutions. This is finding a solution. You can't be guaranteed to say I have all solutions. So let's work through this one and I'll show you the method. I'm going to be told that the answer to this x is between 3 and 4. So I now know what I can do, the value of x needs to be somewhere between them. And if I want the answer to be to one decimal place, I can use certain amounts of logic to work out what's happening. Now, sometimes you say show, and we show that there is an answer between 3 and 4. And what that means is you try 3 in the equation and show that that number is either above or below 25. Then try 4 and show that number is above or below the 25, and there should be one either side. If they're not one on either side, there may be 2 solutions between there. There might be one solution, but you can show when there's one number below and one above. The exception to that is when there is something like a 1 over x. That may lead to there being things that look like solutions, but there aren't. For you, we don't need to worry about these. We don't need to worry about 1 over x. We're going to talk about polynomials. These are things which only have positive integer powers of an expression. There are no 1 over x's and there's no roots going on. They often complicate things. So we're talking about simple polynomials. So this is a polynomial. Okay. So what's the steps? Well, we say what value of x we're going to try. We calculate its estimate. So the x cubed minus 2x, what's the value? And from that we can say low and high values. So I could try 3 and 4, and that at the end of that I can say the low value is 3, high value is 4. Let's put them into the calculator and check them. So I'm going to put them into a normal calculator first, and then in a minute I'll do another solution, another one showing you how you can speed this up using a Cassion. So if I say number 3 goes into this equation, now I'm going to use the formula technique. So I'm going to type in 3 and tell it to store that in my memory x. Now that might seem like a silly thing to do to start with, but what we're going to do is we're going to put in our expression. So our expression says I want x cubed alpha x, so alpha and then the x which is above it in red, same as the alpha button. I want to cube it, which I can do with shift and the x squared. It depends on your calculator how to find these. You might have to do a power button which is up like that, or something with a square, and 2 alpha x. So I've typed in the expression on the left hand side, and we're going to look at the number. The number that comes out from that is 21. The answer being low or high doesn't come from this 21 being low. Sometimes this number could be higher than that, and then a higher value here would be below it. So the low and high comes from knowing that there's a number between. So really I shouldn't have put this one in yet. So I don't know anything at this point. I don't know if 3 is high or low as a value for x. Let's put in 4 into x. Shift, store into X, there we go. And then I can go back up and select my expression again and press equals, and now it tells me 56. Now I know that 25 is between 21 and 56, so the value is going to be between 3 and 4. Next step is make a reasonable guess. Quite common reasonable ones would be to try 3.5. If I try 3.5, what would my value be? So on my calculator, I could either type in the formula. There's lots of things open at the moment. Just need to get rid of that Python session. So now I'm just going to put in the calculator and try 3.5. It's a reasonable guess. Go halfway. Let's see what's happening. Do not keep going halfway though. Don't keep halving it. The reason being, we want to find out what decimal value is here. So I put that into my value of X. I go up and find my formula and press equals. And that says I've got 35.875. Now this 35 says we're on the big side. My answer 25 is between the 21 and 35. So that means that my value is between 3 and 3.5. So I can try another number. Until I know between which one decimal place values there are, I'm going to stick to using one decimal places. If you start now trying to do 3.25 and 3.125, you can go forever doing that, and you still won't necessarily be able to say what the one decimal place is. So we'll try 3.2. So I take my equation, I put 3.2 into my calculator, press Shift and store it into the value X. Again, scroll up till I get an equation, and I get 26.3687. 26.368. Again, I look at my number, while 25 is below that, so this is the top end. It's between 21 and 26, so it's between 3 and 3.2. So what's the next number to try after that? Let's try 3.1. There's only one other number to try, but I need to know, is it above or below 3.1 for my solution? So I do Shift, store, and I store that into my X, press equals, and then go up to my menu, calculate that formula, and I get 23.591. 23.591. So 3.1 gives me 23.591. That now means that 25 is can be found when I put in numbers between 3.1 and 3.2. Now some people will turn around and say, oh yeah, there's 3.1. Remember, we can round. This number is actually quite somewhere in the middle, and it's not exactly clear. When they're very, very close, sometimes you can say, but you should always check which one of these two numbers is it closer to. Well, we check by finding what number is in the middle, and it's always the one decimal place with an extra 5, and that's the number that was going to tell me which way to go. So I'm going to put in 3.15. and it's the only time I have to put in a 2 decimal number. The 2 decimal number should always end with a 5. So I'll put in 3.15, store it into my value X. Didn't do the store. There's my 3.15, and I press up and select my formula again, and that gives me 24.95875. Well, I only need to know roughly how big it is, so the 24.95 and lots of extra digits is enough for me to know. This is now smaller than my 25. So my answer is between the 3.15 answer and the 3.2 answer. So this knocks out the wrong estimate. All of these numbers in here all round to 3.2, to 1 decimal place. So that is my estimate. 3.2 is an answer to that equation. If you haven't got a calculator that's capable of using the menu, the formulae, X, Y, M, A, B, C, D, E, F, I would suggest you get another calculator, because it is useful to be able to do this repeated trials of values. The other thing is the Casios have a nice feature which I'm going to show you now to show you how I could find this quite quickly. A little point for you is when I'm marking these, I would definitely have to see those two numbers and that number for you to get the marks. You must go either side of the number at 1 decimal place. So if I'm asked for 1 decimal place, I need to be know it's between 3.1, 3.2. If I'm asked for 2 decimal places, I'd have to know, is it between 3.14 and 3.15? I'd have to know, is it between that, and I'd have to show it. So those bits must be seen. There are logical numbers to try, like 3.5, find out if it's high or low. But if from here, we know 25 is quite close to 21, it is acceptable to try smaller numbers. Maybe you try 3.2 straight away and then realise, go below that, 3.1. That is possible. So the 3.5 is optional. You might logically be able to say there's definitely one between these two, but I must see one number either side and the answer on the other side. Okay, so just going to do another example. Okay, so here comes another problem. This time I'm going to use a different calculator to sort this out. I know there are solutions between 0 and 2. So what I'm going to do is I'm going to show you how you can use the better, or the more, let's just put that in. X is between 0 and 2. So I'm going to show you how to use a Casio calculator, which has a nice table function to put in and allows us to find to 1 decimal place again. I'm just going to keep doing 1 decimal place. That's what most questions you'll need to do will work on. So you do 1 decimal place, you always go to 2 decimal places where the second decimal place always has a 5 to check where the answer is. So let's put in my headings. First heading is the value of X that we are trying, the value of the expression. You may see other videos where they say low or high. I still prefer to say low value, high value. So I know each line tells me that I'm zooming in towards the right values. If you just say low or high, sometimes people make mistakes skimming back. So I'll show you in this one what happens as we go through to calculate the values. So let's bring in a Casio calculator. Now these Casio calculators have a strange mode. So to go into it, you press the mode button, and it's this table function. The table thing allows me to create a whole series of values. Now I did show you this when we were doing equations of lines. The fx is the same as working out an expression. So just like I did with the previous one, I could put in x values here and then just type in expressions using the other calculator, like I did here. So I could type in x is 0, shift store into x, and then I could type in my expression 5, use the alpha key to select the x, square it, and subtract alpha to select the red letters x, and cube, which is on a shift, that calculator. I could actually calculate that and it would work through. What value of that? Oh, I said 0, didn't I? So yeah, 0 is going to give me 0. I know the value 2, so if I do shift store into value x, I've got my value stored. I can now go back to my expression and press equals, and now it says 12. So I know between 0 and 2. We've got 0 and 12. We wanted the value 10, so we know it's between 0 and 2 at the moment. Now the Casio calculator allows me to check lots of numbers at the same time. So you start off putting in your expression, 5 alpha x squared minus the x cubed minus alpha x cubed. And we say which values do we want? Well, I want to go between 0 and 2. So I start at 0, end at 2. And the step is what precision do I want to go up in? So if I leave it at step 1, it's going to try 0, 1, 2. But the beauty with this is, as long as I'm not asking for too many points, I can put 1 decimal place. And now this shows me that 0 is 0, that we got here. I'll scroll right to the bottom. I've got 2 is 12. Now, I said earlier that you might be able to make a guess. So the sort of guess we might think for is, I would like to find a number close to 10. That's going to be nearer to 2. So if I use my list, I can actually scroll back and find where is that list. And there I would have to record those two numbers, those estimates. So you might go to maybe 1.5 to show them that you've understood the principle. But what you need to show is the 1.7 was 1.7, wasn't it? Yeah, 1.7 and 1.8 to show that we've gone either side. 0.7 and 1.8. Bring in the numbers, we've got 9.537 and 10.368. 9.537, 10.368. So this one was low, this one was high, this one was low, this one's high. And what I now know is, from doing that one, this is too low, so that replaces my low value. We know it's between 1.7 and 2. And here, this 1.8 is bigger than 10. So I know it's between 1.7 and 1.8. You've got to keep looking backwards in these high lows. I look for this 1.7. Is it my lower side? If it's on my low side, I've got a number. To decide which one's the better one, we need to go in between. Which value is it in between there? Well, the halfway point is 1.75. So this is going to allow me to choose which decimal place is it. So I go 1.75. And in my Casio, what I can do is I can go back to my table. And I accidentally, the cancel button takes it back. I forgot the cancel button. Fx squared minus alpha x cubed, or you could just use the other method I showed you, set the value of x. We know it's between 1.7 and 1.8. And I only want to go in steps of, you might be tempted to put 0.01. If you put 0.01 though, people often jump to the better solution. What we need to go is just 5 in that next decimal place. That will show me my numbers. So 1.75 gives me 9.9531. This value is too low. It's on the low side to 1.8. So all of those numbers round to 1.8, to 1 decimal place. If I was to come back into my video, my table, and press cancel, the function stays the same. And I'd say start at 1.7, finish at 1.8 and go in 0.01. The tendency people have is they try and find the best solution. So they might say that, oh, 1.76 is closer, I'm going to say it's 1.76. That doesn't matter for this rounding. You only need to check that 5. We're only actually interested in that line to choose our best solution. Okay, so you only choose a 5 here. You just want to know what that 5 is. That 5. Now, there are other solutions to this. I deliberately chose the function. The reason this is not solving, I'll show you the graph now. We haven't solved the equation because there are actually 3 solutions. There's one, sorry, I just need to scroll that up a bit. There's one, this graph is 5x squared minus x cubed. And there's one where there's a negative x, minus 1 point something. There's this one we found, which is about 1.8. And there's another value, which is about 4.5. So there are actually 3 solutions to this equation, and we've only found one. So this technique is not solve. We're not solving here. What we have done is we have found. So if they use the word find solutions, you got any method is valid. Solving equations, you have to use an algebraic method that will say this is the answers, and there are no more. Okay, that's the end of that part. I'm going to set you an exercise with some answers. I'll try and put up some work solutions to some of them for you as well. Okay, off you go.